If you were to go for a walk in the forests of Southeast Asia during the Ice Age, you'd probably see a lot of awesome and familiar creatures, like rhinos, tapirs, and hyenas. But an animal once wandered these woods that was unlike anything you've ever seen. About 3 meters tall and weighing up to 500 kilograms, this beast was probably twice the size of a modern gorilla. Scientists call it Gigantopithecus, the greatest great ape that ever was. And for us fellow primates, there are some serious lessons to be learned in how it lived and why it disappeared. So, the story of Gigantopithecus begins with some of the smallest of physical clues: teeth. And they weren't found in the field, but in a drugstore. In 1935, paleontologist Ralph von Koningswald was rummaging through apothecary shops in Hong Kong. He was looking for so-called dragon teeth, the name given to fossil teeth from all sorts of animals that were used in traditional Chinese medicine. And on one of these trips, he found a molar unlike any he'd seen before. The tooth was like that of an ape, broad and flat, but it was much bigger than one from any known species, living or extinct. Von Koningswald eventually determined that these teeth were of an enormous primate, and he named this new creature Gigantopithecus, or giant ape. After this initial discovery, more teeth were found in other medicinal shops, and eventually a few fossil jawbones were found in a Chinese cave. But that was it. Since then, we've found more jaws and thousands of teeth, but no other parts of the giant ape's body have ever been discovered. Even though we have so little of its anatomy to study, we've managed to figure out a lot about Gigantopithecus just from those teeth and jaws. For starters, it turns out there were 3 species of this giant ape, the earliest of which dates back about 9 million years to the Miocene epoch. But the most recent and by far the largest of them was Gigantopithecus blacki. It lived from 2 million to 100,000 years ago during the Pleistocene epoch in what is now South China and Vietnam. Of course, the most obvious feature of Gigantopithecus blacki's teeth is their size. At 2.5 centimeters wide, the ape's molars were more than twice the width of a human tooth. But an even closer look at these teeth has revealed much more than just how big this animal was. For one thing, scientists have been able to use them to figure out who its closest living relatives are. In 2008, a team of anthropologists studied the thickness of the enamel on 10 Gigantopithecus teeth, as well as the shape of the hard tissue underneath it called the dentin. They found that the structure and the composition of the fossil teeth were most similar to those of the only great apes left in Asia, the orangutans. Which is kind of strange because orangutans are arboreal. They spend most of their time high in the trees. But Gigantopithecus was way too big to do that, so scientists think it must have been a ground dweller, which raises a new set of questions. For one thing, what does a 500 kilogram primate eat? Well, its teeth were flat and wide, but its jaws were deep and strong, and all of these features are associated with feeding on tough, fibrous plants. Microscopic plant fossils called phytoliths have also been recovered from some teeth, showing that it fed on grasses, including possibly bamboo, as well as seeds and fruit. But while these physical clues can tell us a lot about the diet of this extinct ape, the chemical composition of its teeth can also reveal to us where it lived and possibly why it disappeared. The trail of clues here begins with isotopes of carbon. Different kinds of plants produce different ratios of carbon isotopes during photosynthesis, depending on what kinds of environments they live in. For example, plants that live in cool, humid climates are typically known as C3 plants, because their way of photosynthesizing results in a 3-carbon acid that has its own unique combination of carbon isotopes. But plants that grow in hotter, drier climates are usually C4, because they do photosynthesis in a slightly different way and produce their own byproducts with their own ratios of carbon. And all of this is extremely useful for scientists because the chemical signatures in these plants are absorbed by the animals that eat them. So by studying the chemistry of Gigantopithecus teeth, researchers can tell not only what kinds of food they ate, but also possibly what its Ice Age habitat was like. At the same time though, fossils of other mammals that lived alongside the ape have been studied too. I'm talking about those rhinos, tapirs, and hyenas that I mentioned earlier. And it turns out they ate some C3 plants, but also C4 plants, which grow in drier, grassier areas. So this suggests that Gigantopithecus probably lived in a mosaic habitat, kind of like a checkerboard of forests and grasslands. But unlike its fellow herbivores, Gigantopithecus preferred to live only under the dense forest canopy and didn't stray into the open, much like modern orangutans and mountain gorillas who are also forest experts. And this specialist lifestyle seemed to work very well. at least for a while. The fossil record shows that Gigantopithecus blacki existed for nearly 2 million years in the forests of Southeast Asia. But these primates lived during a time of great change. The Pleistocene is sometimes called the Ice Age, when glaciers were constantly ebbing and flowing across the land, holding moisture when they froze and releasing it again when they thawed. This constant fluctuation meant that the Pleistocene habitats were in an ongoing state of flux. Things could be warm and humid for 20,000 or 100,000 years or so, which would allow forests to grow, but then it would freeze again and draw all the moisture back up to the higher latitudes and grasslands would spread. Somehow, Gigantopithecus managed to survive the first few of these glacial periods, but 100,000 years ago in the Middle Pleistocene, something changed. Another cold snap occurred that was simply too severe for the apes to survive. As the ice expanded, so did the grasslands, shrinking the forests of Southeast Asia. Without the habitat it needed to survive, populations of Gigantopithecus shrank dramatically, and by 100,000 years ago, the last of Gigantopithecus had vanished. So Gigantopithecus managed to thrive for as long as it did because it was a specialist. It found the right combination of food and habitat to suit its probably massive need. But in the end, its specialized habits left it vulnerable to an ever-changing world. And in this way, its predicament is similar to that of many modern animals, including its closest living relatives, the orangutans. Orangs are forest specialists too, only found in the dense jungles of Borneo and Sumatra. But for decades, their unique forest homes have been reduced by things like logging and wildfires. With much of their habitat gone, all 3 species of orangutan are now considered critically endangered. Still, some researchers hold out hope that we can help these distant cousins of Gigantopithecus and of us by continuing to learn the story of the greatest ape that ever lived.